Good morning, Phoenix class, and welcome to today's maths lesson. Today we are starting a new unit on statistics. So in this unit, we're going to learn to calculate the mean of a set of data. We're going to find missing data using the mean. We're going to look at a range of charts and learn how to interpret them. So looking at pie charts and line graphs and any other charts. Here's some vocabulary that we're going to be looking at. Most of those you should understand now, but we're going to cover mean first of all. Segment is also another one that we will learn. And we're going to be using bar graphs to help us understand. So today's lesson, I can calculate the mean. Our first problem. What is the average number of marshmallows on a stick? So first of all, we're thinking about what the term average means mathematically. Let's have a look and see how many marshmallows we've got on each stick. Well, if we count up Katie's here, we'll find that she has got 12. Olivia has 8 and Lexi has 7. So how can we make sure that they all have an equal number of marshmallows? So every child, we've got 3 children there, has to have the same number. So here again, we can see that Lexi has 7, Olivia 8, and Katie 12. So if Katie gives 2 of her marshmallows to Lexi and 1 of her marshmallows to Olivia, then we can say that they all have an equal amount. So 7 plus 2 equals 9, 8 plus 1 equals 9, and 12 minus 3 all equals 9. So we've got to remember that average can mean different things. But one way to think about the average is that we need to try and make every group an equal size. And this is called finding the mean. So we can make a definition. The mean is an average. We find the mean by making every group an equal size. So that's really important, that finding the mean is making every group an equal size. So the children find 6 more marshmallows in the packet. What would be the average number on a stick now? So we've got to think about, again, sharing those marshmallows out equally. There's 2 ways that we can do this. I'm going to actually do method 2 first. We know there are 3 children and we found us 6 extra marshmallows. So we can share those 6 out equally between the 3 children. So we know that they all get 2 extra. We'd already worked out that the average number was 9. The mean was 9. So 9 plus 2 is going to give us 11. But I want us now to think about method 1. So we now have 33 marshmallows in total. So we want to share out the 33 marshmallows equally among the 3 children. So 33 is our dividend. 3 is our divisor. So 33 divided by 3 equals 11. So the mean number of marshmallows on a stick would be 11. Remember the definition? The mean is the size of each part when a quantity is shared equally. So the mean is the size of each part when a quantity is shared equally. How could we turn that into a generalization or a STEM sentence? Could you do that? So Bella joins the other children. She only has one marshmallow. What is the mean number of marshmallows per child? Do you remember what the mean means? The mean is the size of each part when a quantity is shared equally. And from that, we've got a generalization. The mean is the total of the numbers divided by how many numbers there are. So let's see if we can work this out. So Lexi has 7 marshmallows. Olivia has 8. Kate has 12. And Bella only has 1. So remember, the mean is the total of the numbers. So the first thing I'm going to need to do is add all those up. So 12 plus 8. Well, that's going to give me 20. I've added those two first because that's a really nice, easy sum to do. Then I'm going to add the 7. Well, now I've got 27. But I can't forget about Bella. So I'm going to add the 1. And that will give me 28. So the number of marshmallows in total is 28. How many children are there? We've got 4 children. Okay, let's have a look at this STEM sentence and see if this can help us. The dividend is 28. Do you remember what dividend means? Dividend is the number that you are dividing. The divisor is 4 because there are 4 children. So I can put my divisor in there. The mean is 28 divided by 4. What is 28 divided by 4? I hope you're all shouting at the computer. So we know that 5 times 4 is 20. So 6 times 4 is 24. And 7 times 4 is 28. So we know that the mean number of marshmallows is 7. Let's have a go at this one. What is the mean number of cubes in each group of towers? What do you notice? Can you explain it? So again, what is a mean? The mean is the size of each part when a quantity is shared equally. And how do we find it? Well, then we can use the generalization. The mean is the total of the numbers divided by how many numbers there are. So let's have a look at A. So we've got 1, 2, 3, 4, 5 cubes there. We've got 4 there. We've got 5 there. We've got 6 there. And we've got 10 there. So remember, the mean is the total of the numbers. So our total is going to be 30. The dividend, therefore, is 30. What's our divisor? Well, how many sets of cubes have we got? How many towers? We've got 1, 2, 3, 4, 5 towers. So the divisor is 5 because there are 5 towers. So how am I going to calculate the mean? The mean is 30 divided by 5, equals 6. Sorry about my writing there. That's a 5. about this second group? What I'd like you to do is pause the video here and see if you can work out the mean yourself. Okay, how did you get on? Let's add up the numbers in our towers. So we've got 5 there, we've got 6 there, we've got 5 there, we've got 6 there, and we've got 8 there. So once again, we have 30. So the dividend is 30. The divisor is 5 because there are 5 towers. The mean is 30 divided by 5, which is 6. So what do you notice? The mean for this set is 6. The mean for that set is 6. But the towers are not the same, are they? How could that be? I'll let you think about that one. Okay, into our practice book. Question 1. Draw 3 new towers that show the mean height of these towers. So in your new drawing, in that second grid, all your towers are going to be the same height. So let's have a look with these. 1, 2, 3, 4, 5. So that one's 5 high. So that one's 6 high. And that one's 4 high. What's 5 plus 6 plus 4? 15, isn't it? How many towers are there? There's 3. So 15 is the dividend. 3 is the divisor because there are 3 towers. So the mean is 15 divided by 3, which equals 5. So on your second group, you're going to draw 3 towers. Each of them is 5 high. 1, 2, 3, 4, 5. So you're going to have 3 identical towers. So in B, this is the same sort of thing. You're going to end up with 4 identical lengths of counters. I'll let you do that one. Question 2. What is the mean of the number of marbles in the bag? So we've got to add them all up first of all. So we've got 3 and 5 and 5. Are you adding these up for me? And 5 and 5. Oh, and 2 rather. Sorry. So we've got 20 in total. How many bags are there? So the dividend is 20. The divisor is 5 because there are 5 bags. Therefore, the mean is 20 divided by 5, which equals, I'll let you work that one out. Question 3. Match groups of dice that have the same mean number of dots. So we need to find the mean for each of these. Question 4. Calculate the mean for each set of measurements. So in this one, we're going to do 10 plus 20 plus 30 plus 40. That will become the dividend. How many numbers are there? The divisor is going to be 4 because there are 4 different numbers. So your dividend divided by your divisor will give you a mean. Same with the last 2 there. Circle the group on question 5 with the greatest mean. So A is meaning 4 plus 1 plus 1 plus 2. That will give you the dividend. How many different numbers are there? There's 4 different numbers, so the divisor is 4 because there are 4 different numbers. Remember how to find the mean? Dividend divided by divisor equals the quotient, or in other words, the mean. When you finish those, either do the need more practice or go straight on to the challenges. You've got 3 there to do. And then finally, you're going to do the answer to this as your reflection. Describe 2 ways to find the mean of these numbers, 4, 5 and 6. You can go back and have another look at the video if you're struggling to do that in 2 different ways. Have fun today. Bye.